Day 50, Honors Physics, Conservation of Momentum, Problem 28. So here on the left, we do start off with the classic conservation of momentum. We have a child running with a speed of 4 meters per second, so her momentum is 120 units to the right. Here, the blue item here is the toboggan at rest, so it has no momentum to start the problem. Total momentum starting, that will be conserved, will be 120 units of momentum to the right. So once the child jumps onto the sled, they're like one big mass now. I'm going to treat that as item number 3, object number 3. The total momentum there has to be the 120 from the previous part because momentum is conserved. So the 120 is conserved equals the mass combined. 30 plus 12 is 42 kilograms. So the velocity of the child on the sled, at least initially, before friction starts to slow the sled down, is 2.86 meters per second. There's two ways then to proceed to finish off to figure out the distance it slides. This goes back to last unit. We can figure out the work done by friction by multiplying the force of friction times the distance. We will need to find the force of friction. So let me do that, which is 25 newtons rounded off to 2 sig figs. That's the force that will slow the sled child system down. And once again, you can do this two ways now. You can do F net equals ma, assuming that's the only force slowing down the sled, which it is. Well, by the way, where does 420 come from that I used to find the force of friction? Well, remember, force of friction is mu, which is given, times the normal force. The sled and child together are 42 kilograms, so their weight is 420 newtons down, so the support force, the normal force from the ground or the snow, is 420 newtons up. So that's the normal force. That's the frictional equation, mu times the normal force to get your normal, to get your frictional force. All right, so once again, you can use that F net equals ma to figure out the acceleration of the child toboggan system, and do v sub I equals 2.86 down here. V sub f would be 0, and then use that acceleration. You can do it that way, or you can do conservation of energy right now, which is what I'm going to do. In other words, figure out the kinetic energy that we have here. It's 1/2 times m, which is 42, times 2.86 squared. That will give you a kinetic energy the sled has. Now what's going to happen is, I'll let you do that. That's the amount of energy that will then dissipate into heat because of friction. So what you'll do is you'll be taking that number, that value that you compute there, and plug it up into the work done by friction. So that number will go there, and we know the force of friction is 25, so that goes there. And then you can figure out the distance that the sled slides. I'm not sure it's any faster than using kinematics, but I always try to use conservation of energy, and that's one way to do it here.